So recording is there. So this one is, I think you are clear now. You can go through the video again, and then again you can learn it, practice it. Okay. So now let us come to, yes, yes.
Sir, you wrote a point here. When fourth priority group is present in plane, configuration obtained preferably by exchanging group, putting fourth group below the plane, the configuration will be opposite of what we get with the exchange. So in first case, we get configuration R. Shouldn't it be S?
Now which one? This one.
Sir, first one.
This one.
After one exchange.
Yeah. After one exchange, we got S, no?
After one exchange, we got R.
No. You see here, we have exchanged with this one, OH has come here, hydrogen we have brought it here. Just see, OH has come here, hydrogen has gone here. This is what? 1, 2, 3. So 1, 2, 3 is what? The rotation is what?
S.
Anti-clockwise. Yes.
S.
I wrote here R, that was a mistake. Got it?
Yes, sir.
So if this is S, this must be R. Am I right? Because we made one exchange from here. Hello?
Yes, sir.
Okay?
Yes, sir.
Okay. Now let us come to the next point. This is what is important also. R and S configuration in Fisher projection, because wedge projection to Hartig we write. Normal situation, what we use? We use always Fisher projection. Am I right? Normally what we use? Most of the time we use Fisher projection. Yes or no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, here also you should be very careful. Now, in Fisher projection, groups are placed in vertical, that means up, down, and horizontal positions. Horizontal means right, left, right and left, and up and down. Now, rules for the R and S configuration in Fisher projection of a chiral molecule. In the Fisher projection, what we have to do? Now, rule for, just see it carefully. Now, here, if fourth priority group, because we are always interested in the fourth priority group. If the fourth priority group in vertical position, if it is present in the vertical position, that means either up or down. Either this one or this one, because this is fourth priority group. If it is vertical position. Now, if the fourth priority position is either here or here, then it remains same as what we have done. That means priority group in the vertical position, clockwise if you get, it is R. Anti-clockwise if you get, it is S. Anti-clockwise of other three group, 1, 2, 3 group. So it is very simple here. That means here, now you see, this is 1, 2, 3, and fourth priority group is here, down. So either if fourth priority group is here or here. Now here, whatever rotation you are getting, 1, 2, 3 rotation is what? Anti-clockwise now. If it is anti-clockwise, so this is S. And here, because it is going to be its mirror image structure, if this is S, this should be R. Let us see, 1, 2, 3, and this is. Am I right? So it's very simple. If your H is here also, the same rule persists. If it is here also, the same rule will apply. But now the question is, what we are telling, is it really right or wrong? Am I right? We have just framed a rule. But whether this rule is correct or wrong, how to judge it? Why should you accept a rule without its verification? Yes or no?
Yes, sir.
As a student of science, nothing should be accepted, nothing should be taken for granted. You must test it, you must verify it and see whether it is right or wrong. So how to judge whether what we are telling is correct? Tell me, somebody give me some idea how to judge it. Tell me, give me some idea. Come on, your time is running. You are having a next class also. Yes, how to judge? Some idea you give me.
So we can extend SR to which projection?
Yes, we convert now. We convert the. We know how to convert a feature to wedge projection, isn't it? And in the wedge projection, let us see whether this is really S or not. So what is this wedge projection formula? So this will be simply this COH. H will be here, and then this side is angle, so CH3 will be on the top, and OH will be here. And there you see whether it is. So testing is just to have this. You see here. This is the structure. COH is here, H is here, CH3 will be on the top, OH will be. Now, because H is falling here in the plane, so we make one exchange, bring with the backside group. So OH comes here, H goes there. If OH comes here, H goes there. So 1, 2 rotation is 1, 2, 3 is clockwise rotation. So this gets R. If this is R, this should be S. So this was S. This is also S. That means what we are telling is correct. Yes or no?
Yes, sir.
Yes. So you see, nothing should be taken for granted. So this is, now let us see the fourth periodic group is in the horizontal position. Horizontal positions, which are horizontal position? Right or left? Either this one or this one. If it is fourth periodic group, we are talking of the fourth periodic group only. So this will be, if your fourth periodic group is in this rotation, opposite to that of the previous case. If you are getting clockwise, it is not R, rather it is S. And if you are getting anti-clockwise, it is not S, rather it is R. Simple. So let us see here. Now here the fourth periodic group has come here. Fourth periodic group has come here. Now what is this one? 1, 2, 3. 1, 2, 3. What is the rotation? Rotation is becoming anti-clockwise. So actual molecule should be clockwise. That means R. And here, if this is our mirror image structure, should be S. 1, 2, 3. It is S. Here also, we should not take it for granted. We have to verify it, and verify it by wedge projection. Let us see. So test it by writing wedge projection. So what is wedge projection of this one? COH, and OH will be here. COH is here, OH is here. And this side will be CH3 is coming here. So this will be on the top. And hydrogen. So here already this fourth periodic group is going backside. So we don't have to do anything. So this is 1, this is 2, this is 3. So 1, 2, 3 is what? Clockwise direction. So this is R. That means this is also R. That means this is nothing but. So whatever we are telling is correct. Are you comfortable? Hello?
Yes, sir.
You got my point?
Yes, sir.
Yes, sir.
Okay. Now let us see that exchange rule. Exchange rule, same as what we have done in the with the wedge projection. 1 exchange means opposite, 2 exchange same. So conversion of one configuration to the other, rule same as with the wedge structure. So here, just see, this is R. With one exchange, it has become S. Two exchange, it has become R. Now, I am just giving you,
Sir,
yes.
in this page, the first one, why it is R? Can you repeat it? In this first one.
Too many repetition.
Hmm.
This is what we say. If four priority group in the horizontal position, whatever rotation what we are getting, this we are doing mechanically using a rule what we have proposed. 1, 2, 3, 1, 2, 3 rotation is what? Anti-clockwise, right? If you get
Yes, sir.
anti-clockwise, in actual case it was S, but it is not S, it is opposite of that. So it is get R. Now whether it is really, yes.
Here, can we exchange the position of least priority group and we
No, that
then
is,
we can,
you see, when you are in a hurry, all these things you cannot do. First of all, you should satisfy yourself whether what we are telling is right or wrong. If you do keep on exchanging, suppose in a competitive examination, your time is also very important. Huh?
okay, sir.
Yes or no? Time is
Yes,
important
sir.
or not? You can do this
Yes,
one,
sir.
and yes, what you are telling, you are right. You bring it here and OH here and see what is the rotation. If OH comes here, 1, 2, 3. 1, 2, 3 rotation is what? Anti-clockwise. Anti-clockwise rotation means what? Is going to be going to be S. But we have done one exchange, so this should be R. Whatever you say, you are going to get the same result.
Yes, sir.
Okay. So here also same rule for exchange. If we make one exchange, so here you see I made one exchange. H we have brought here, OH here. So it has become it was R, it has become S. Two exchange, this OH and what we have said. Okay, another exchange here, OH and CH3 we have brought it. OH has come here, CH3, it has again become R. Fourth priority group is here, so there is no problem. So it is going to be R. And here you see, simple rule. Simple, suppose CH3 is here, H is here, OH is here, and COH is here. Now, what you do to make it to get another equivalent structure of this one, what it is? What is the configuration of this? 1, 2, 3, 4. 1, 2, 3, 4 is what?
R.
So this is going to be R, and it will be R because your fourth priority group is at the vertical position. So this is R. Now, if you change the position of the group to keep the configuration same, then what you do? Exchanges, you can do it like this. You keep any group fixed. Suppose CH3 group you fix, keep it here in its position. Other three groups which are there, OH, H, COH, you can rotate them in clockwise or in anti-clockwise. Suppose you bring here OH here, COH will come here, and H will come here. So this is also going to be R. Just check whether it is R or not. 1, 2, 3, 4. So 1, 2, 3. What direction you are getting? Anti-clockwise. But because H has come in the horizontal position, so it should be clockwise. That means this is also R. So we can change one structure to the other structure by keeping their configuration intact. R should remain as R. Then only this structure is same as this structure. Okay?
Yes, sir.
Another exchange. Let us see. I can make another exchange. Suppose I keep now OH group hydrogen in its position same. Let us keep hydrogen position same. And other three positions, if I change clockwise or anti-clockwise, the configuration will remain same. So if OH I bring here, if OH is brought here, COH must come here. COH come here and CH3 will come here. Now you see whether it is R or not. 1, 2, 3, 4. 1, 2, 3, what it is?
R.
It is R. So that means this is R, this is R, this is R. That means all are same. All are same. Okay? So exchanging position and getting the same configuration, it is very, very important thing that you have to do. You have to remember. You can remember in different ways. One exchange means opposite configuration. Two exchange means same configuration. And another two exchanges can be brought like this, keeping one group in its position. Other three groups can be rotated in clockwise direction or anti-clockwise direction. And then that structure will remain, will become same. Oh, okay. I will stop after this. You see, this is another very, very important thing that rotation of Fisher projection by 180 degree in a plane and out of plane. Rotation of, just see, I think you have not done these things in your college. Did you do? Hello?
Yes, sir.
You have done it? All
Yes,
these
sir,
things?
but we forget it.
Oh, forget it. Okay. I don't know whether you have done it or really done it or not. Rotation of Fisher projection by 180 degree. That is 180 degree means what? If it is here, suppose if I rotate it 180 degree means what? It will become this. That is completely upside down. Now here this molecule, if it is there, what is this one? This is 1, 2, 3, 4. So what it is? Anti-clockwise, right? But because fourth priority group is in the back horizontal, so this becomes clockwise. So it is on. Now, if I rotate the molecule in the plane, 180 degree in the plane, that means what will be 180 degree in the plane rotation? That means OH will come here and COH will be here. So what it is going to be? Yes. COH will be here, H will be here. That means complete rotation of the molecule. In that case, in the plane when you are doing, R remains as R. If it is R here, this in plane rotation will make it R will remain as R. See here. This is 1, 2, 3, 4. 1, 2, 3. What it is? Clockwise, anti-clockwise rotation. But because this is in the horizontal position, so this is clockwise rotation. So this is R. So this one you remember, rotation of 180 degree rotation in the plane is R will remain R, S will remain S. But out of plane rotation, that means you just turn it like this, turn it. That means the rotation you are making, so these two groups will remain in their position, but hydrogen will come here, CH3 will go there. In that case, if it is R, the structure will become S. You see here. This is out of rotation. COH and OH is there. You just turn the molecule like this. Hydrogen comes here and CH3. That means that way. You understand the point, rotation like this. And here the rotation is in the plane, within the plane. So these two rotation. So these two rotation will become opposite. So this R has become S. You see here 1, 2, 3, and this is 4. This is just see the rotation. 1, 2, 3 is what? 1, 2, 3 is coming as clockwise, but because it is in the horizontal position, so this should be anti-clockwise. Am I right? Hello?
Yes, sir.
Okay.
Sir.
So this will be, I think this will be your compounds with two more than what, let me see quickly. I can just give it. 2 chiral centers, same thing you have to do. You have to keep the rotation, what is called, same rule will apply, but individually you have to give. So here, what is your carbon number? This is your carbon number 1, carbon number 2, carbon number 3, carbon number 4. So carbon number 2 is going to be S and carbon number 3 is going to be S. Because you see here 1, this will be priority number. This will be your priority group number, priority number 2. This will be priority number 3. Oh, no, sorry. This will be priority number 2. This will be priority number 3. And this is 4. So 1, 2, 3 this is the direction. So it should be opposite direction because it is 4 priority group is in the right hand. So this is S, this is also S. And you see here, and this is its mirror image structure. So if they are SS, this should be RR. And here you see, this is R, this is S. This is R, this is S, and this is going to be S and R. And they are the mirror image structures. 3 and 4 are the mirror image. So RS has become SR, mirror image structures. So that way. So 1 and 2 are enantiomers, 3 and 4 are enantiomers, but 2 and 3 are not enantiomers, they are diastereomers because this is RR, RS. Or this one also is going to be diastereomers. This one also going to be diastereomers. Okay, optical, I'll forward this DL configuration. We'll do it in the next class. Let me stop here. Let me stop sharing. Stop sharing. And then also I'll stop pause recording, stop recording.